Hello everybody, welcome to another qualitative chemistry lesson. This is Cotton. Cotton, say hello, hello. She's a bit scruffy, she needs a haircut and a bath, don't you darling? You're a bit scruffy, you're a bit scruffy. Okay, let's do some chemistry. Alright, let's check that that's recording because otherwise, yep, I'll be very upset because I've already recorded this whole thing once. Now I'm doing it again. Alright, here we go. Alright, so here we have some calcium sulfate with a bit of water in it. So we've got 7.15 grams of it. If we heat it up, we get rid of all the water and we're left with 5.65 grams. So that must be just the calcium sulfate. So there's a few different ways that you can do this type of question, but I quite like doing it the way that's kind of similar to how we do empirical formula. If you'd like to have a go at the question, which I do recommend doing, then please pause the video, have a crack at the question, and then resume and see if my method's the same as yours and if you like my method or your method better and whatever. All right, so I'm going to want to find the number of moles of both calcium sulfate and water so that I can compare the number of moles so that I can get a ratio. To find the number of moles, I need the mass and the molar mass of both. Oh gosh, that's some thick ink, isn't it? Let's just sort that out. Let's go that thickness, I like that. Alright, the mass of calcium sulfate is, according to the question, 5.65. The molar mass of calcium sulfate is, and I went and did that earlier, it's 136.1. The mass of water is the mass of the whole thing minus the mass of calcium sulfate, isn't it? Which is 1.5. And the molar mass of water is 18.02. Okay, now we need to be able to compare the number of moles of both to get a ratio. So calcium sulfate and water. The number of moles for calcium sulfate is the mass divided by the molar mass. So 5.65 divided by 136.1. For water, the same thing. 1.5 divided by 18.02. And that equals 0.0415 and 0.0832. So I think the ratio is pretty clear straight away. To find the ratio though, we would divide both of these numbers by the smallest number. So 0.0415 divided by itself and 0.0832 divided by 0.0415 gets us, which is not much of a surprise, 1 to 2 ratio. Therefore, we have twice as much water as we do calcium sulfate. So the formula is calcium sulfate with 2 lots of water. That's that. All right. This next question is a standard empirical formula question. Very straightforward empirical formula. Once you've found the empirical formula, you need to find the molecular formula. So please pause and have a go at this now. Okay. So to do empirical formula, we need to set it up. Communication is really, really important here. So we're looking at carbon, hydrogen, and oxygen. And the first thing that we want to look at is what is the mass of 100 grams of the stuff. If you don't put this in, then it shows a lack of understanding and you will lose marks. So the communication is really important in empirical formula questions. So because this is in percentages and percentages are out of 100, if we look at what the mass is out of 100, then we can say in 100 grams of the stuff, we're going to have 40 grams of carbon, aren't we? We're going to have 6.71 grams of hydrogen, and we're going to have 53.29 grams of oxygen. Then we go to moles per 100 grams. So we divide each of them by the molar mass. So 40 divided by 12.01, 6.71 divided by 1.008, and 53.29 divided by 16 gives us 3.33, 6.66, and 3.33. So we get our empirical formula of C. Oh, I didn't finish the ratios. I'm so sorry. Silly me. So dividing each of these numbers by 3.33, I'm going to get ratio 2, 1. Oh my God, what am I even doing? 1, 2, 1. Okay. Therefore, the empirical formula is CH2O. Now, to find the molecular formula, so the molar mass of our actual compound is 60.05. So I'm going to find the molar mass of my empirical formula and see how much bigger the actual compound is. So the molar mass of CH2O is going to be 12 plus 2 plus 16 approximately. We get 30.03. Okay, so let's compare those. 60.05 divided by 30.03 is 2. So it's twice as big. The real thing's twice as big. So we double everything for the molecular formula. So we get C2H4O2. Done. Okay. And here we have another just really straightforward phys-sci problem. So again, just have a crack at it and then check your answers with mine, assuming I do it correctly. Okay, so you might like to pause now. Okay. So I've got 85 tons of iron being produced. So therefore, what mass of CO2 would be produced? So the mass of iron is 85 tons. And I just want to convert that to grams because anytime we do stoichiometry, we use mass in grams. So there's 1,000 grams in a kilogram, there's 1,000 kilograms in a ton, so there's 1,000,000 grams in a ton. So I'm going to times that by 10 to the 6. So now I can do the number of moles of iron is the mass divided by the molar mass. So it's 85 times 10 to the 6 divided by iron's molar mass, which is 55.85. And that gives me an answer of 1.52 times 10 to the 6 moles. Now, if I want to find the mass of CO2, I need to find the number of moles of CO2. So I need to check the ratio. So I've got 3 CO2s and 2 ions. So to find the number of moles of CO2, I times by what I'm trying to find, which is CO2, and I've got 3 of those. I divide by what I've got, which is iron. I've got 2 of those. So if I do 3 divided by 2 times 1.52 by 10 to the 6, I get 2.28 times 10 to the 6 moles. Okay. Now, the mass of CO2 is the number of moles times the molar mass. So 2.28 by 10 to the 6 times by the molar mass, which is going to be 12.01 plus 2 lots of 16. and that gives me an answer of 1 by 10 to the 8 grams, and if I convert that back to tonnes, it's 100 tonnes. Okay. Next, B. So that's part A. Part B. What mass of iron 3 oxide must have reacted? So now I want to find the mass of iron 3 oxide. So I needed half as much of iron 3 oxide as the amount of iron that I got. So that's my ratio of iron 3 oxide to iron. So the number of moles of iron 3 oxide is the number of moles of iron times a half as much according to the ratio. So 1.52 by 10 to the 6 times a half gives me 7.60 by 10 to the 5 moles. So now that I've got the number of moles, I can find the mass. So the mass of iron 2 oxide is the number of moles times the molar mass. So 7.60 by 10 to the 5 times by, so we've got 2 ions, which the molar mass of iron is 55.85, and 3 oxygens. And if I put that into the calculator, I get 1.21 times 10 to the 8 grams, which is equal to 121 tonnes. And that's it. So the next thing is excess and limiting reagents, which we're going to look at next term. I don't know that we'll do anything else for chemistry this term because next week is supposed to be all student-free days, but I probably will give you an essay task to work on since you guys don't really have anything better to do at the moment. But it'll be due sometime in term 2, so you'll have a bit of term time to work on it as well. Okay, thank you so very much for listening, and goodbye.